In this example, we are going to eliminate the parameter t to obtain an equation in terms of x and y. Part A, we have x equals the quantity of t plus 1 power 2 and y equals t plus 2. The idea of this is to solve for t and then replace it into another equation that we don't use to get x in terms of y or y in terms of x. This is the algebraic expression, so it's easier to work on y equals t plus 2 by solving for t. So we get t equals y minus 2, and then substitute into the x equals the t plus 1 quantity squared, where t is y minus 2. We get y minus 2 plus 1 power 2 and result in y minus 1 squared. And this is the parabola opens to the right in this way. Now we're gonna see the trajectory of this equation. Since the first t is negative 10, the x equals negative 10 plus 1 to the power second, or 81, and y equals negative 10 plus 2 equals negative 8. So the first coordinate would be 81 comma negative 8, and then go into the direction that go toward to the t equals 10, where x equals 10 plus 1 power 2, or 121, and y equals 10 plus 2, which is 12. Then the coordinate or the last coordinate of this trajectory is at 121 and 12. So to get the graph, that would be the beginning part at 81 comma negative 8 and go up this direction and go stop at the coordinate 121, 12. And next example, we have x equals e to the power 2t and y equals e to the t plus 1, t from 0 to 25. These two equations is in the exponential term. For the e to the power 2t, you can see this as e to the t to the power second. And that means it's more convenient to work on the function y as e to the power t plus 1, if we can rewrite y in terms of e to the power t, so we can replace it into the x equation. Now, back to the y. Since y is e to the t plus 1, solve for e to the t. E to the t is y minus 1. That means we can replace e to the t with the term y minus 1. So we get x equals the quantity y minus 1 squared, which is the same parabola as what we got in part A. Parabola opens to the right. Again, same situation, but the parameter t will tell you where to start, where to stop. Now let's look at the graph at the beginning point, at the ending point. As t equals 0, x equals e to the power 0, which is 1, y equals e to the power 0 plus 1, or 2. So the first coordinate will be 1 comma 2. And the last coordinate at t equals 25, x equals e to the 50, and y equals e to the 25 plus 1. Both of them are positive number, e to the 50, e to the 25 plus 1. Now, the parabola that we have supposed to be something like this. Since the beginning is at the coordinate 1 comma 2, and the trajectory going from the low t to the high t, and the last point is at e to the 50, e to the 25 plus 1, then the portion of the parabola will represent the graph of this parametric curve. Another example. C is cosine of t, y is 1 plus sine t from 0 to 2 pi. This case, we have sine and cosine function. We have to look at the trigonometric identity. Since the cosine t and sine t, they have the same argument or the same t parameter in the back there. So one of the trig identities that we use the most would be the cosine square t plus sine square t equals 1. and it's more convenient to write it in the form of square of the cosine and square of the sine and put the x and y terms together. So we're going to solve for the cosine t for the first one. And basically cosine t is x. For the second equation or the equation of the y, we have the sine t equals y minus 1. Now, since cosine t squared plus sine t squared equals 1, we set it up as a trig identity. And then replace the cosine with the x. So we have x squared plus the quantity y minus 1 squared equals 1. Then we get the equation involving x and y. And this equation is a circle with the center at 0, positive 1,